myself, I would go change format a little bit. What we're going to do today is part intro to Python, part intro to object-oriented programming, and part how I do challenges personally. So I'll go ahead and figure out how to share. Do I need to be added to share?
You should be good to go right now.
All right, so just me lacking the ability. Hey, there's a share screen button. That's what I was going for. All right. So we're going to dig in with basically, well, who here knows Python already? Show of hands or voices or whatever. All right, so Charles knows some Python. Yeah. I'm going to assume that the people that I can't see are also not holding their hand up. So it's been said by one of the Python core developers that one of the greatest things about Python is you can take somebody that understands how to program pretty well, and you can have them writing good Python inside of a week. So, hey, Arlie said they know some Python. Brittany knows some. All right. Lawrence said he knows half a hand worth. All right, so Python, if you don't know, instead of having things like braces and semicolons, everything's really controlled by white space. It fully expects that when you define a function, everything inside that function is indented. If you write a loop, then everything inside the loop is indented. Things like this. So Python is really great. At least I think so. One of the things that I feel, Brittany, I'll be glad to take some questions after we get rolling a little bit. So one of the things that I think Python is best for in prototyping is the fact that I don't need to decide what my function is going to return. Ever. Like I can change it 100 times and I can return a whole bunch of things. So let's see. I'll just set up some foobar function. It takes in whatever I want. This thing. All right. And then we can say A is foo, B is bar. We can say one of the cool things that we could do is that we have first class tuples. Basically means you have something that's vaguely like a list that doesn't need to be expressed as such. So we can actually say that C equals A comma B. And that's valid. We can do print A comma B comma C here. One thing I like to do when I'm testing stuff is I like to use the unit test package that's built into Python. So no outside dependency. And I use PyCharm as my dev environment, my IDE for Python, and it will let me run tests just with the click of a mouse. Test foobar. And then I can just call foobar with whatever I want. So I can run this test right here. It executes. I didn't really assert anything, so it's not going to fail, but we can see foo, bar, and then C looks like this collection of foo and bar. Something else that's interesting, this is composition of a tuple. We just named a tuple that came from two things. You can also use this to swap variables like this. Effectively, what you're getting is A equals B and B equals A without a temporary variable. What it's actually doing is it's letting this be a tuple and letting this be a tuple, and it's taking these values and then shoving them into there. So then if we jumping between VS Code and JetBrains, it's slightly disorienting, but we manage. AB equals BA, foo bar, bar foo. So we just swapped them around. These first class tuples are great for many reasons. Swapping variables without an intermediate is nice. You can also come here and say DE equals C. And then we can print here our CDE. So we have a packing of tuples or a composition of these two into a single thing. And then down here, we're taking the single thing and putting it into two things. So if I run this again, we'll see we have them shoved together and pulled apart. So that's really cool. That's kind of one of the things that's underlying that we could return. We could return foo, comma, bar. And it looks like we're returning two things when we're really just returning a tuple. And a tuple is a native enough thing that you can handle it directly there. And then we can catch this as stuff and things equals that foo bar. And at this point, we really don't even care about this input, right? We're not doing anything with it. But then we can print. I'll mention something else that I really enjoy. F strings are formatted. Charles, that's great. I'm going to touch on that in just a second if you give me a minute.
Cool.
Stuff, things. All right, so it's basically a template literal for a string. We call them F strings. Lots of other languages have an F print or F string of some sort. It's a format call, right? Python, 90% of the things that make Python nice and easy to look at are just sugarcoating of things that exist everywhere else. So we can do this stuff, foo, things, bar. So we just got those two things and brought them back. Everything cool so far? All right. So then what's the difference between a tuple and a list? All right, so we can say pieces equal foo, comma bar. Then we can do parts equal a list of lorem and ipsum. All right, we can print pieces we can print parts. All right, so one thing we initially see is that we have syntax difference. We could also, without using the explicit list call here, we could use square brackets, and that's just interpreted as it's going to be a list. So let's say, what if we wanted to get the first element of each? All right, can we do that? All right, that works. What if we wanted to set the first element? Let's say pieces 0 equals new, and parts 0 equals new. All right. So you can't do an assignment to an element of a tuple. That's pretty much the only thing that I've found that is really a difference here. You can, so you could actually do pieces equal a list of pieces. If I'd have done that a line higher, we'd see that it doesn't complain at us. So we can convert cleanly between a tuple and a list. We can also do parts equals tuple of parts, and now it's complaining over there because we can't assign on that tuple. All right, so that's kind of gets in the difference of a tuple and a list. Any questions here?
Is it cool to put like different types inside a single list or a single tuple?
Oh, yes, you can.
Nice.
Let's just play with, we can say, you can explicitly put parens around, and then we can have a string, we can have a number, we could have an empty list, we can put an empty tuple, we can put my class, and it works. It just works. There's a common thing when you're dealing with types in Python, something called duck typing. We don't ask anything to be a particular thing. We don't ask elements to be numbers by default. We don't ask elements to be numbers or strings or anything explicitly. There are some type hints that exist in newer Python. I personally haven't messed with them because I don't do anything with Python that's remotely production. It's usually scripts and just puzzles and things like that. So cool. We have tuples, we've got math, we've got something else. We can have data is, if we use curly braces, we have a dictionary. One can be foobar, X can be stuff, Q can be a list, and then we can print data here just as a default. We're doing something. And then in a list, or in a dictionary, you can actually, that is not what I was wanting to do. You can access things as if they were an array. So you could do like print data, you know what? Let's just go 1. You could do that. And we get the element that corresponds with the key 1. All right. If you're familiar, if anybody's familiar with Java or maybe some more rigid programming languages, might be familiar with a hash map. Hash map is basically, you have keys that are hashable and immutable that refer to elements of value. So numbers and strings, what is the self doing? Oh, good question, Matthew. So what you might see in other languages as this, the instance of the class that you are is self. So when you define a function on a class, its first argument is self. In context, if you make, let's do thing is my class. This is going to work because Python is automatically going to pass the object itself as its first argument. Right now, this thing is without purpose. You could print self here, and you could print thing here. Let's go. So thing, we can run this and it's going to be the exact same object. Constructor basically, and this kind of goes for any language, you technically, the language makes a thing for you and then tells the constructor to finish making the thing. Like, I need one of these. Now, whatever you need to do with arguments and whatever you need to do to an internal state, go ahead and finish setting that up. And that's what that does. I'd love to take any questions. Brittany, if you have something specific that's not deep into object orientation, general Python stuff, I'd love to take that now. All right, for lack of a question or any comments from anybody, I'm going to start moving forward a little bit. I got some kind of different stuff. So another cool thing about Python is that the way that object orientation works, we have a lot of kind of built-in things that we can get exposure to. So let's say we have this thing, and if I was to do for a and dir think thing, if underscore in a print A. All right, so this basically, you got a function, technically a method because it's in a class, right? Got a for loop definition. The default loops in Python are a for each style rather than an index-based loop. If format is without parentheses, so is the for loop. What we're going to do here is we're going to look at the parts of a thing. When the parts of a thing as a class object include all of these functions. And there's some cool things that you can do with this. In order to play with those, we really need some actual data. So tell you what, let's make this a person. And our person needs an age and a name. Self.age is age. Self.name is name. Cool. So we can make, maybe we don't use thing. Maybe we use Charles. Maybe we'll make his name lowercase so that it follows convention. Name is Charles. Age is, we'll go 27. All right. So we have this thing. Now, what if we wanted to be able to compare two people? You can do this any number of ways, but let's say that for our purpose, we want to do EQ, self and other, if, let's say, return self.age equal other.age. All right, so get back to what we talked about duck typing. This other, I know nothing about it. It could be anything. A classic example of duck typing is that you could have a Charles, and you know we don't need to know that they're all ducks. We're going to ask duck, it'll quack, and then maybe Charles says the word quack, and we got something when we asked it to quack. So as far as we're concerned, it's a duck. It's really no further than that. We're gonna ask it to do duck-like things, and we're gonna assume it's a duck if it could do those things. Also, another part of example would be that, like the mallard, the yellow duck might off the ground and hand it to you. You asked for a feather. Maybe Matthew doesn't have a feather. And, we asked him to get a feather, and he's like, "Nope. That's, as far as we're concerned, you're just not a duck, and that's all we need to worry about." And if we asked Matthew to give us a feather and he didn't have a feather, then whatever. It's gonna throw an error. Matthew doesn't have to give us a feather. We don't care if he has a feather. So we can have two people. Let's say Corey is a person. We can use positional. We don't have to give the name of the argument. Corey, comma, 35. All right. So maybe, all right, we don't care about that stuff at the moment. Let's just print Corey equals Charles. False. All right, there we go. So, well, what do we want to do? What if Corey less than Charles? I don't know. I have no clue. All right. Let's see.
I'd never say that.
Let's see. Well, we should probably define something else. Let's look at what that thing said again. These other things. I know this is greater than, this is greater equal. This is less equal and this is less than. So we're looking at less than right now. So if we do def, what if we just do less equals? Let's see if that works. Return self dot age less than other dot age. Let's see if that works. Less than not supported. All right, well, what if we change this? That was a person. Oh, well, we're not actually messing with that. So I'm just going to comment it out for now. All right, well, what if we put an equal here, less equals. Less than is not supported between string and int. All right. So it looks like these are out of order. All right, so this was supposed to be 35, Corey. Helps if you know things. Using keyword arguments helps us avoid that, where we can just put in whatever we want, whatever order, as long as we provide the things that it's looking for, we're okay. All right, so let's try that again. Okay, it's okay. False, that's what we were looking for. Print test result, comma. So usually use single quotes in Python, not mandatory. All right, there's that. All right, we should probably, if we're doing less equal, we should probably do less equal inside, right? Well, if we just do LT, return self age less than other age, then we could come down here and we could take this equals off and we could just do less than. And it works. Now, a fun thing here, I'm going to go ahead and just do, we'll do the GT and the GE. GT, return self age greater other age, GE. GE. That's the one I was looking for. Return self age greater equal other age. Now you could define these all on different variables, to where you can do some really weird stuff with this. If you really wanted to, you could do some really weird stuff with this. But we're just doing age, right? Less than, less equal, greater equal, or equals. All right, so let's do, all right, we got Charles and Corey. All right, let's assert Charles not equal Corey. Let's assert Charles less Corey. Assert, and these are not value judgments on Charles by any means. Let's equal Corey. Assert not. We'll assert Corey greater Charles. Assert Corey greater equal Charles. All right, let's see if that stuff works. Yeah, it works. So we got those. Let's see what else. What other cool stuff does this let us do? let's say people is a list of Charles. Let's do Corey, Charles. Let's print people. Now let's print sorted of people. Oh, we need to run this test. Okay, well, we don't really know what's going on in there. We know that these are in different order though, right? All right, so what if it'd really help if we had some way to represent this. So let's say, let's return an F string of name hyphen age. Oh, it'd be helpful if we use self, right? All right, so now if we do this, we see first we had Corey first, and then we sorted and we got Charles first. So by implementing these comparators on our class, we can now sort instances of our class just by using the built-in functions of Python. It will automatically sort your items because you defined your class to have these comparisons.
Do you know how many different comparisons you'd need to define in order for the sort to work? Like, would you just have to define less than, do you think? Would you have to?
Let's find out. This is one of I think the coolest things in programming once you get a level of comfort. All right, less than not supported between these. All right, so maybe it's not less equal, maybe it's just less than. All right, so let's do it again. There you go. All you
There you
need
go.
was less than and it'll sort.
Cool.
And then you could, let's say we have a person named Steve that's 12, his name's Steve. All right, let's throw Steve in the middle. All right. So then we can do this again. And we can do reverse is true on that. And now we got Corey, Steve, Charles, Corey. You know what? That's kind of annoying. Let's all right. Nah, okay. So apparently I got these backwards. Repr is a string representation of the thing that you're using. STR is what you get from casting something to a string. So while this didn't exactly work, what I can do is I can now do print the string of Steve after that, and I just get Steve. So we have two different string representations that we can use. Typically you would use like a string representation as something for internal debugging, be a little more verbose, a little more data in that. And the string is something that would be more user oriented. If you wanted to cast something to a string, this is what you would get. So these are all things that you can just kind of play with. These are sometimes called magic methods. Sometimes they're called dunder methods. And there's a whole bunch of them. You can, an odd, interesting thing. We can def multiplication. Return self age times other age. And here we can print Steve times Corey. Really weird to think about, but like that built-in multiplier operator can be loaded up. You could also do, I believe another one would be armol. Which is the other way around if it was going to be different. If you cared what thing was on the left and what thing was on the right of something for an operator. I can't for the life of me think of what you would use this for. I think Charles might have some ideas in some higher math, but I'm currently blanking.
Yeah. I was wondering, since it seems like what we're doing here is it kind of boils down to like, if you want to do math on these people, what we're talking about is their age, right? Like that's kind of what all these end up meaning. And
Well,
I'm wondering
that's what we are
yeah,
here.
yeah. But I was wondering, is there a way, kind of like if I'm asking for a string, I want the name. Is there a way that you could just define the number version of this person is his or her age, and then I just don't know. I'm curious if that could be useful.
I don't
Yeah.
know, but
Okay.
now I want to find out.
Sure. Yeah, me too.
Int return self age. All right. So then what happens if I get rid of this right here? Will this multiplication work? No, but I cast them to integers. It will.
I like it.
So what I did to start finding these, this bit right here. Here, I'm just going to cut this out. And I'm kind of abusing the whole idea of a test here. But we can just use a string here. And we can see that anything there's a set attribute to where you could have a complex object and you could like set age on it. That would be fun. Let's see, let's do a set attribute key value. If key is age, self.age equals value. And then we can do get attribute, we can do if key equals age, return self.age. Oh, this item, not key. I just rolled on through without catching that. Elif key equals name. Self.name equals value. If item equals name, return self.name. Now we could come down here. We could play with. All right, so that's that stuff. Trying to organize this so that later on we can kind of understand it and share it with other people, right? That's got Steve and Corey, so let's just grab those two, bring them up here. That makes sense. All right. We were looking at. All right. So we've got Steve. Let's say, let's print Steve name. Whoa. Max recursion depth. All right. Name is Steve name. Did that get mad? That got really mad. Are we sure it's mad about this one? Yeah, it's mad about this one. Set attribute. All right. So it wants to set attribute, but we didn't. We had age on and name. We did something weird. Let's see if we can just do Steve name equals Steven grew up. Steve grew up and he doesn't want to be called Steve anymore. So we're going to call him Steven. All right. Still doesn't like that. If key is A's. This is weird. I don't know what we're breaking here. It is not happy. But you know what? It seems to be coming from set attribute. Let's print key value. Let's see what's going on. Age 12. Oh. So somehow messing with the set attribute on this is doing weird stuff. I don't know how to fix this right now, but it's an interesting thing. I'm pretty sure that there's a way that you can do this. I'm pretty sure that there's a way that you can do this to where you refer to it in this way, but I honestly don't know what it is right now. And we've only got 10 minutes left, so I'm gonna fall back, and we're gonna rip that out and not worry about that too much. I do have a thing, and I think we still have time to do it. I have found a challenge for us to try to hold our standard format a little bit. I'm going to grab this. basically we have this check coupon that you should make sure that, well, here. All right, I'm going to pull some of this stuff out as we go. All right, so let's do, I don't need this person anymore. And you know what? Let's make a new Python file. This is going to be coupon checker. All right. Well, def coupon, and we're going to have this entered code, correct code, current date, expiration date. Maybe instead of this, maybe we just make a date class real quick. Be the fun part of this. Technically, we're checking entered code is correct and the current date is less equal to expiration date. So we're going to have a date and we're going to give it self, comma, date string. All right. So the format here is this. So we could take month, day, year is date string dot replace I want to get rid of the comma for nothing. It doesn't like my formatting. Dot split. I can get day, month, year. It's going to take out the comma. We got that. And we can come up here. We go unit test. And for test case. Class test date is the test case class. Test close date. Yes, we're gonna take this, but we wanted that to be in quotes. Let's make them single quotes so it's more Python typical. Unexpected argument. Okay, maybe this shouldn't be date. Maybe it should be my date. What don't you like? Oh, I'm doing it wrong.
That's more like C#, I think.
Yeah, so, oops, there we go. Or Python or Java.
Or Java, cool.
All right, so we got that. Let's see. Print month, day. Yeah. Let's just do that real quick. We got 5 minutes. All right, we got that. All right, so we probably actually want day, comma year to equal integer day, integer year. Probably want to, and this is probably something I should have done before, Let's do months equals, I'm gonna cheat. I'm just gonna do September is 9. There we go. And then we'll probably do months, and then I'll do self.months of month lower of month. Why am I doing this wrong? Changing languages is always hard. That looks good. So now we can, probably not gonna look a whole lot different. There we go. We've reformatted this. So then, if we wanted to less than self and other. All right. So what are the ways we can do? All right. Self is less than other if year, if self dot year less than other dot year, return true. If let's see, first we probably want to do if self, let's do this the other way around. If self year is greater than other year, return false. If self, then return true. Otherwise, we know that the year is the same. Then we need to look at if self dot month is greater than other dot month, return false, greater, yep. And then if self dot month less dot month, return true. Yes, Ariel. Self is kind of like this. So then if you've got down this far, then we know that the year and the month are the same. So we need to look at the day. Oh, hold on. Month, day, year. Oh, you know what? All right. Month, something.
Now the coupon's still valid on the last day, right? That it's on the date that's printed, right? So would you want to do like the last one, self that day less than or equal to the other day? Like if it happens to be the same.
Yeah, that would be the most useful. But that would change things a little bit.
I think it's, well, let's see.
Greater.
I think if you just did line 30 it would probably work, right? Because you'd only get to that. Yeah, I think that'll work. Maybe.
So now we could actually do bad day is September 11 2001. Better day equals, nope, that's not what I wanted. July 1st, 2001. That's my birthday. And I believe I turned 14 that year, maybe. That sounds about 15. Yeah. Let's do print a, no, better day less equal bad day. Let's try it. We did get done. We have a way that you can construct a date, and you'd probably want to fill this out with the rest of the months. You can construct a date from a string, and you can compare two of them. So what you would want to do here is you would def test coupon. We have the two tests that we have here. We want to assert current is less equal expiration date. And then we've got this other pair is expected false. Assert not those with less equal in the middle. Let's see if this works.
Do you get October in there?
Oh, yeah, probably need October in there. September 5th, 2014, less equal October 1st, 2014. 14 is equal. Month, September is less than October. Did we do our checks weird? Month is less. Self month greater than. All right, we've hit something weird. It was the first one.
Oh, well, you're actually testing less than, or you had defined less than, not less than or equal, right?
No, we went and did LE is less equal.
Oh, okay. Oh, sorry, I can't read it.
So we would expect that September 5th, 2014 is less than October 1st, 2014. 2014 is the same. Month is less, so we should be. Month is less than other dot month. Return true, should be here. Did we mess up? September is 9, October is 10. Something's weird. I'm not 100% sure what it is, but we're already 5 minutes over.
Maybe we can figure it out in Slack.
Oh, you know what?
Yep.
If you want to use your class, you kind of need to use your class.
Oh, yeah.
Here, let's go Alt, Enter, Enter, Enter. My date. Oh, that was weird. Alt, close. Oh, there's this weird thing over here. Oh, it's still in multi-caret. Nine, 5, 14, 10, 1, 14. Something's weird. I'm not 100% sure why.
Looks like the first one worked, right?
Oh yeah, that one did. So then this one, September 5th, 2014. I copied something wrong. I think these tests are wrong. Oh, that test was not
Yeah,
wrong.